On behalf of the Eyes on Earth Consortium, a very warm welcome to the online edition of the Eyes on Earth Roadshow. My name is Martijn Seiger and I am your host today and tomorrow. In the coming 2 days, we will inform you on satellite data applications and especially about the Copernicus system. In this session, you will learn about the Copernicus satellite system, contributing missions and the various services which are delivered by the entrusted entities. During this presentation, please submit any questions into the Q&A text box on your screen. After the presentation, the speaker will try to answer as many as possible in the time available within this session. Please welcome Mr. Stijn Vermoote of the ECMWF, the European Centre for Medium-Range Weather Forecasts.
Good morning. A warm welcome from my side. I'm Stijn Vermoote from ECMWF and I'm going to talk about Copernicus and the Copernicus services. So, as indicated, my name is Stijn Vermoote. I have a background in environmental and climate services, business development and funding of research and innovation activities. I'm the User Engagement Manager for Copernicus Services at ECMWF, which stands for the European Centre for Medium-Range Weather Forecast. ECMWF is an international research institute and a 24/7 operational service producing global numerical weather predictions and other data for member and cooperating states. We are the entrusted entity for the Copernicus Atmosphere Monitoring Service, CEMS, and Copernicus Climate Change Service, CEMS. So let me explain a little bit what Copernicus is. Copernicus is the European Union's operational Earth observation and monitoring program, looking at our planet and its environment for the ultimate benefit of our citizens. It's based on observations from sentinels or satellites, and this is turned into added value services for the benefit of society, companies and policymakers. So it's a true user-driven program with free and unrestricted data access. Let me first give a little bit of history. Copernicus was not there since yesterday, so it has been based on a long-term process of research and political investments. It all started in 1998 with the Baveno Manifesto. Baveno is a small village in Italy, where scientists, with the support of policymakers, decided to build an Earth observation program, which is global and which is operated at by European investments. This was turned then into a large research-oriented program, GMES in the beginning, which was then changed into the name Copernicus. And since 2014, we are fully operational. Some of the activities started a little bit later, but we can say that Copernicus at the moment is a truly user-oriented service, and it's also there for the future. So at the moment, we are looking into Copernicus 2, which will start in 2021. The first component of Copernicus is a space segment. The space segments, these are the satellites. And the satellites are operated by our partner ESA, European Space Agency, and EUMETSAT. And we have 6 different constellations. We have Sentinel-1 to 6, which consist of different satellites with different payloads, with different features. At the moment, we have 4 different Sentinel missions in operations, and 3 others will be launched this and next year if all goes well. There are some new ones which will also be launched under Copernicus 2, but the focus here is of course on what we already have, and it's already a wealth of information available directly from these satellites. It's not only Sentinels which we use in Copernicus. There are also a lot of other contributing missions which we rely on. So we have the Sentinels and we have other satellites, European satellites, but also American and other satellites are used, and they all feed with observations into the Copernicus program. The second component of Copernicus is what we call the in situ component. In situ data consist of observations from the ground, the sea, or airborne sensors, reference and auxiliary data licensed or provided for use in Copernicus. So that's the official title. So this in situ component is also very important because it's used to validate and calibrate Copernicus products and data, but it's also a very reliable information service where it's available. So these are already two components. Then the third component are the Copernicus services. So the two services, they turn this observational data, be it from satellites or in situ measurements, combine it with models, so we can also do some forecast and derive some value-added information and data for end users out of this. So I will provide you some insights in the on the most important elements of the Copernicus services. We have three services focusing on the three components of the Earth. The first one is land, and if we think about land, we think about ecosystems, biodiversity. Agriculture is of course a very important one. Energy, water, natural resources, urban planning. And the land monitoring service as operated by the GRC and the EEA focus on three different levels. So you have the global level, think about products on vegetation, energy, water. We have the pan-European level, so at European level. And then we also have the local level. An interesting product is, for example, the Urban Atlas at local level. So that's land. The second phase of Earth is the marine, the oceans. It's also very important. And we think here about marine safety, marine resources, coastal and marine environment, climate and meteorological forecast, but also everything linked to transport, tourism, environment, and energy. So CMEMS, or the Marine Environment Monitoring Service, is operated by colleagues of Mercator Océan in France, and they provide also a series of different products which are focused, of course, on marine aspects. We think about sea level, ocean salinity, ocean temperature, sea ice, winds, ocean currents, and ocean color. The third sphere of the Earth is the atmosphere. So this brings us to the Atmosphere Monitoring Service, or CEMS, which is operated by ECMWF. If we think about the atmosphere, we think about health, environment, pollution, also climate or renewable energy. And we provide different products to serve these needs. We have products linked to air quality and atmospheric composition, on climate forcing, the ocean layer and UV radiation, solar radiation, emissions and surface fluxes. So these are the three spheres of the Earth on which Copernicus provides services. Then we also provide additional services which are more horizontal, so which cover both the Earth, the land, marine and atmosphere. So the first horizontal service is the Emergency Management Service, CEMS. We think here about disaster, emergency situations, or in case of humanitarian crises. And in those cases, CEMS can be activated. Typical products which are provided under CEMS are risk and recovery mapping, like reference maps, pre-disaster situation maps or post-disaster situation maps. Rapid mapping, so the same things which are activated in a very speedy situation to provide support to civil protection, but also early warning. We think here about floods or forest fires. A second horizontal service is security. We think about border surveillance, maritime surveyors, or support to external actions. And there's a wide range of activities covered under security, going from coastal monitoring, pre-frontier monitoring, maritime surveillance, vessel detection, vessel tracking and reporting, but also road network status assessments, conflict damage assessments, crisis situation mapping, or border mapping. So this brings me to the last horizontal service, a very important one, of course, climate change. Climate change service is also operated by ECMWF, and we think about mitigation and adaptation actions, pollution, environmental aspects, health, energy. There are different elements which are covered under climate change. What's provided under climate change are consistent estimates of essential climate variables, products which support mitigation and adaptation strategies, global and regional reanalysis. And reanalysis are products where we look into the past, but then also seasonal forecasts, so up to 6 months ahead, and long-term climate projections up to 100 years ahead. So these are the 6 different services of Copernicus. It's illustrated in many aspects, and a dedicated website has been developed to illustrate this. You can find the details in the slide presented. The first example which I want to illustrate is linked to security. On the slide you see an image of a traffic jam at a crossing between Austria and Hungary, stretching up to 30 kilometers into Austria. This situation leads to some security issues in the sense that we have to assess how the flow of traffic goes and how it impacts the crucial transport of medicines and other goods between borders. The closure of borders or other measures have been taken by member states to fight the spread of the pandemic. And this is an illustration how security service was of help already at the beginning of the pandemic. A second example is linked to emergency. Here you see a map of Turin. In purple you see hospitals and other medical facilities. In light green you see sport and recreational areas. And in turquoise you see open air markets and places. The reason why we want to map this is to help the local civil protection first to assess where the main risk areas are for transmission of COVID-19, but also to take evidence, to take stock of the medical facility measures which have already taken. This map was produced using the Pleiades satellites. So in the beginning I explained about the Sentinels, but also contributing missions. This is a contributing mission, and this has been done through the Copernicus emergency rapid mapping facility. A third example is an example from the Sentinel satellites themselves. Sentinel 5P, and some of you may have seen this in the news, provided some very obvious observations from space on pollution. Here's an example of nitrogen dioxide concentrations over Italy and a comparison between last year and this year on the change of air pollution due to the lockdown situation. Of course, this type of information has to be taken with some care, because you still have influence by weather, you have influence by the chemistry of pollutants, and you also have to take into consideration that a satellite measures the full column of the atmosphere and not necessarily what you observe at the nose level, which is important to know the impacts of air quality on health. That's why we also have CEMS, the Copernicus Atmosphere Monitoring Service, And here I illustrate you a time series of concentrations of pollutants, here again NO2, versus historical figures, and we take an average between 2017 and 19, and the status of the lockdown situation. So you see how the trends evolve over time, and we can compare this now with the lockdown situation. It illustrates that it's not that straightforward always to make assessments, and that you always have to take into account different aspects before making an assessment. My last example is linked to C3S, the climate change service. And here I want to illustrate the COVID-19 Explorer application. With this Explorer application, we have plotted information on temperature and humidity, and versus the number of fatalities. The number of fatalities, the number of death cases due to COVID-19 as provided by the Johns Hopkins University. With this, we want to illustrate what Copernicus is able to do, what C3S is able to do. We have on one side a rich source of climate information. We have an application which is easy to use, which is attractive, which provide maps and graphs. And it illustrates that you can also combine it with other information provided by the public health community, and you can combine these things. With this, we want to illustrate also that it's up to the communities to combine these things. We give the source code for free away, so it's open and free again, and everyone can play with this information and data as they wish for further research, but also for other purposes. So this brings me to my last slide. In a nutshell, use Copernicus. Copernicus gives a unique data availability. It's open and free. It has an expanding portfolio of Copernicus services. So every month you have new services or new updates of services, and it's ever changing, taking into account user feedback and user requirements. It's operational. It's a long-term funding. As indicated, we will start with Copernicus 2 in 2021, and it's there for the long run. And we also provide multiple grants for innovative ideas and training options. So it's a true service, and it's a true service also to foster the market, to stimulate user uptake, and to stimulate small and medium-sized companies and research institutes to use and combine our information and derive user-oriented products out of this. Thank you for your attention, and enjoy this session of the Eyes on Earth Roadshow.
Oh, thank you, Stijn, for this very fine presentation. During the presentation, many questions were submitted in the text box. Participants can still submit their questions. We have gone through a few questions when we prepared, of course, and I would also like to invite you to pick a few in the coming 10 minutes. So I will keep the time. At 11:59, we have to close the session because our next speaker is then waiting. That will be Mr. Federico Fierli from EUMETSAT. The first question I would like to raise is how to collaborate with Copernicus in general. Like it's about data access, it's about brands. Can you explain a little bit?
Yeah, first of all, thank you again for the invitation, and I hope that everyone enjoyed my talk. And I'm happy to take your questions. So, Martijn, on your question, so how we can or people can participate in Copernicus. So Copernicus has different ways to access the data. So you have the DIAS. This is a platform which allows people to access the data in an efficient way. For Copernicus Climate Change Service specifically, we also have the Climate Data Store. And in this Climate Data Store, you have everything available in a uniform way which includes both data and applications and tools. And that's only one thing of the story, of course. So people can download the data, they can also play with the data online. But what's also specific on our program is, well, as made clear already, it's an operational program, and it comes with decent use support. So there's a dedicated team who help users to find their way into the massive amount of data and to help them to find or to abstract what's really relevant to them. And then we also have a program for training and knowledge transfer, so they can get trained on specific elements, be it as an expert user or somebody who still needs to learn about this. So these are different components which we offer. Besides this, of course, there's a lot of documentation which is available. So if you go to the climate data store, for example, you see different documents which explains how the data can be used under which conditions. So these are the typical elements which you would expect from a service. So we are true service. Another thing by which people can participate are use cases, demo cases, and of course, in the different service components, you have this. You have it in the maritime service, but you also have it under the climate change service and the atmosphere monitoring service. Use cases which illustrate, which help small companies or research institutes to turn their ideas into potential business applications.
Okay, well, thank you very much on this. One additional question to this topic. Does it apply for the collaboration for everyone or only for private individuals, or are there any limitations on systems or on companies or so on, or is it open for everyone?
It's a good question indeed. Copernicus is open and free for everyone, not only for Europeans, for everyone. Everyone can download and use this data and applications. There's some data which we broker, so data which belongs to other entities, and for this you may need to accept certain terms and conditions, so there's a license maybe, but for everything what has been produced based on Copernicus is open and free. And what's more important, it's not only open and free, it's also quality assured. So there's a quality assurance behind this. So you can say when you use Copernicus, it's a little bit like what you have on your laptop, the Intel Inside, which gives an indication of the quality of the processor. In fact, you can also see it with Copernicus. Copernicus is quality, is data of very high quality, and that's what is something what makes us unique, I think.
Okay. I got a special question coming in about does this also apply for the Sentinel-5P data sets? Could you tell or where these can be found? Is it at you or is it at another entrusted entity, or where?
Yeah, so it's not only the derived data and products as provided by the services. So in my presentation, I gave a presentation about the 6 services, but also the satellite data as such can be derived, and this is managed by our colleagues from ESA, the European Space Agency, and EUMETSAT. And this data can be directly downloaded from their platforms and used as such. So this also includes Sentinel-5P data. Okay, Carlos, I hope this answers your question. We've got another question coming in, I will read it from the screen. Mm-hmm. So what's the update frequency and maximum resolution of satellite images that can be freely available with the Copernicus program? Yeah. So maybe it's not something which lies only with the ECMWF, but if you can maybe give some vision on this question, and we will ask maybe again on Federico's on the next presentation. Yeah. So I think it's a question from Sam. Thank you for the question. Indeed, there's no straightforward answer on this. So the update frequency and the maximum resolution really depends on the product. So in one of my first slides, you've seen the different Sentinel missions, and it all comes with their own specifications. And what I would advise you to do is to go on the website for each of the Sentinel missions and have a look at this. And this comes with a different frequency, but also the resolution is dependent on this. But what's true is that it's all open and free and can be downloaded as such.
Okay. Okay, then we got a question coming in from Richard. To what level can you provide technical support and how to access the data? Maybe the answer is already given to a part of this question, but...
Yes, so Richard, indeed, so there is a technical support for the data. So we have a user support team, it's a small but dedicated team of 5 people for the climate change service, but also for the other services. You have dedicated teams who are working on this and which work like proper support teams, which come back to you with an answer within a certain time frame. And of course, this comes with this is mainly focused on technical requirements and access of the data. People who have problems with downloading data or the interpretation of the data or the usability of the data, all these type of questions can be answered. If it's straightforward, you will have an answer quite quickly. If there's a need for technical support by scientists, by experts, it can take a little bit longer, but that's part of a service. So we can provide you with a short link if needed, or you can drop me an email if you need more information about this.
Okay, thank you. We got a question in from Sue or Sao, sorry for not pronouncing the name right. But does Copernicus provide any kinds of programs for students, such as internships or workshops, or maybe only for the ECMWF?
So there is, at this moment, there is no dedicated program for students, but we have training material which is focused on students. So one of the things which I can mention is that at the moment there's a big MOOC running, so a massive open online course on Copernicus, on the different components of Copernicus, and I would advise everyone to have a look into this because it's very interesting and it tackles a lot of different things which Copernicus has to offer. So the MOOC is one element. And then in the different service components, and again, I like to refer here on the climate change service component, we have user learning services. And in this package, we have also some dedicated material focused on students. And then here we mean people who are more like in secondary school level. We also started to look into options to fund some activities for teachers. For example, with the lockdown all over Europe, we see that people need to get educated at home, people at primary school, secondary school. And an example is an online tool which we developed with our partners of the World Energy and Meteorology Council. And this is a demonstrator focused on education for the use of climate change information and energy. And you can play with a lot of things. And if you want, I can also show you the link or send you the link if you drop me.
Okay, very good. Well, thanks a lot. Well, this was also some kind of an insight in some future activities which you are planning. For now, we have to close this session, and thank you once again, Stijn, for sharing your expertise with us on in the Copernicus domain and telling us about the ECMWF. We hope all the participants enjoyed our program so far, and we invite you to be around when Federico Fierli from EUMETSAT will do his presentation. So thank you for now. Thanks again, Stijn, and hope to see you around. Thanks a lot.
Thank you, and enjoy the rest of the event.
Thank you very much. Our next speaker is Mr. Federico Fierli from EUMETSAT. the European Organization for the Exploitation of Meteorological Satellites. Federico will inform you about the effort it takes to process raw satellite data to information. In other words, the do's and don'ts in using satellite data. After the session, Federico will answer a few questions which you can submit in the text box on your screen during the presentation. Federico, the floor is yours.
Good morning, my name is Federico Fierli. I am officer in EUMETSAT and senior scientist at the National Research Council in Italy, and I am an expert in atmospheric composition and pollution, and I work on the user support and the training. I'm happy to be here, and even if virtually, and to discuss with you some examples on what we can do and what we can obtain as information from satellites, focusing on pollution. And today we will talk about something that is really on time. So how the satellite can detect the impact of the lockdown to face the coronavirus crisis on the pollution at European and world scale. Before all, we need to introduce what is the Copernicus program, and more in particular how the satellite program contribute to Copernicus. Copernicus is the main program from the European Commission at the European scale for monitoring the Earth and the Earth environment. It comes from the heritage of previous programs like the CEMS, and has different fundamental component. The component of the infrastructure, and the infrastructure is composed by observation, both in situ and satellite data, and the component of the services that include climate, land, marine, emergency, and security, and atmosphere. Of course, these components are working together, and the observational part fits and improves the quality of the service that the Copernicus program wants to provide, free for everyone in the Commission and in the world space. Concerning the observation, of course, satellites are a fundamental part, and this effort is carried out on behalf of the Commission and of the Copernicus by the European Space Agency and by EUMETSAT, and also the agency and the EUMETSAT are in charge of the distribution of the data. As additional detail on the satellites, the Copernicus program has baptized this program as Sentinels. Sentinels to survey what happens on our planet, and is a multi-decade, is a 30-year program with different types of satellites and different types of observation to cover a broad thematic ensemble of data. We start from the Sentinel-1 up to the Sentinel-6, and each one is specialized with different type of measurements. We scan from the radar imaging of Sentinel-1. We go to the multispectral with the Sentinel-2. They are both already in orbit. The Sentinel-3, and there are already two Sentinel satellites in orbit. The 3A and the 3B is devoted to the ocean monitoring and also to monitor some atmosphere and land parameters. The Sentinel-4 is a brand new and is supported by EUMETSAT and will deal with atmosphere, and it will be the first geostationary satellite measuring atmospheric composition and pollution. Then the Sentinel-5P, that is a precursor of the upcoming Sentinel-5 and has been launched in 2017, and both Sentinel-5P and 5 are dealing again with the atmospheric chemistry and atmospheric meteorology. And the last in program is the Sentinel-6, that is again an altimeter. In addition to this, new missions to observe the carbon dioxide that, as we know, is a key component, is the key component for the anthropogenic climate change, are planned and will be part of the Sentinel constellation soon. The first point that we needed to clarify is what a satellite observes and how it compares to what we see as humans, as inhabitants of the planet. The satellite is observed from the top of the atmosphere. The polar satellites, they orbit above our heads at around 600 kilometer height, while the geostationary at some thousand of kilometers. So they see our planet from above. And the signal that they get is an electromagnetic signal in different wavelengths that is emitted and comes from the ground. But this signal also crosses all our atmosphere. And as we know, the atmosphere is composed by different layers that have different chemical composition, have different features as the presence of the clouds. And then, as you see in the top plot, we have a filtering of the original signal that is coming from the ground, that you can see as the red curve, as a black body emission, that is a physical quantity that is produced by any body that has a temperature that is below the 0 Kelvin. And in blue you see what is measured by a satellite. So you see that there are all these small lines. That means that the radiation is filtered by the atmosphere, and the position of these lines depends on the type of gas, of the type of component that can absorb the radiation at a certain wavelength. And the depth of these lines, so the amount of absorption, depends on the efficacy for absorbing for each species, but also from its concentration. Basically, this is the way that the satellites help us to measure the atmospheric composition. We receive at the ground those spectra, and with the specific codes, with the specific algorithm, and with a different variety of techniques, we are able to estimate the amount over all the atmosphere of the specific gas that has caused this type of absorption. Along the atmosphere, several things can happen. Okay, the first one is the presence of clouds. I mean, clouds often, depending on the wavelengths, but very often they act as a mask, and they screen the atmospheric radiation. So in presence of clouds, the satellite cannot give any information on the composition of our atmosphere. Then, even if we are interested, for instance, for quality and for the pollution on what happens at nose level, we have to take into account that the signal that is measured by satellite is sensitive to a series of atmospheric layers. And here, in the figure that you see, is an ozone measurement from a LiDAR. LiDAR has the property to sample the whole atmosphere, and you see that in function of height you have layers of different concentration of ozone, and we have to take into account that the satellite makes a form of average on the tropospheric column, and then this signal superpose to the one that comes from the ground. Also, the geometry plays a role. The geometry of the observation depends also on the type of orbit of the satellite. You see here is an EUMETSAT image that represents on the top the path of the polar satellites. So they make a continuous orbits around the planet, and then there is a repetition time. So the satellite do not always survey the same area, but this area changes, of course, due to the Earth rotation. Or the satellite can be geostationary, and once a satellite is geostationary, observe always the same part of the Earth, but they cannot observe the Earth as an entire body. So you need a suite of satellites to have a full coverage of the Earth that is more centered around the equator. However, what is very important with satellites is the fact that they provide a global view. That they can operate for a long time, and then can provide a long time series, so also providing information on what is the climate impact, for instance, of the atmospheric composition. They are operated in an operational way, so in principle they provide a continuous flow of information, and thanks to the spectral resolution, they can measure different type of species. And so what we can be observed from space, we give here some examples. For instance, we can observe the fires in Australia in 2019, and here you see an image of Sentinel-3 data. These are visible data, and you see the fire plumes that are produced by the intense fires in Australia in the last winter. You see them as plumes that have a sort of continental size. You can detect the most polluted areas, and here you see the data of a gas of nitrogen dioxide from Sentinel-5P, and these are above India. You can see the effect on the single Indian town, and also the track of the main roads, and the uniform pollution, for instance, into the Gange Valley. And you see the image, the photo from the arc of the city of New Delhi. You can monitor volcanic eruptions, and this is the example of the Eyjafjallajökull volcano eruption in 2014 that has led to the lockdown of the aviation. And you can see the plume as the sulfur dioxide, as a sulfur dioxide signal, and sulfur dioxide can be observed by satellite and is one of the components of the volcanic plume emission. You can also monitor the effect of livestock and land use. This is the example of ammonia that is produced by farming, mostly by farming, and you see in this image the data from the YASI satellite, the YASI instrument above the METOP satellite. Is a concession from the University of Brussels, and you see that there are several areas in Europe where there are very high concentration of ammonia. And these are mostly located where the most intensive agriculture is done. For instance, in the Po Valley, in the Nile Delta, in the Netherlands area, and in some parts of Spain. You can also see the effects of societal behavior on the impact on pollutants. For instance, we have monitored the effect of the economic crisis from 2007, and this is a map of the change of a pollutant of the nitrogen dioxide above Greece from 2007 to 2011. So across the most intense phase of the economical crisis. The economical crisis, of course, correspond to less consumption and, for instance, less use of transports, and this is visible from space as a signature on the pollution. And now I would like to switch on the effect of the lockdown measures. So to see what is seen by satellite, has been seen by satellite in the last months. We start with an iconic image that is provided by Sentinel-5P satellite and has been elaborated by the CNMI, by ESA, and by S&T. And these data are available on the website that is marked below. This is in the frame of the Copernicus Programme. And this is an estimate of the reduction of the NO2 concentration, the nitrogen dioxide concentration over the main areas. Why we observe this decrease? I mean, nitrogen dioxide that is represented below is a compound made of nitrogen and oxygen, and can be produced in very intense combustion. So the main sources comes from transport, from production of heat and electricity, from industrial processes, and to a lesser extent from residential heating and commercial and institutional heating. So mostly with the lockdown and the reduction of the traffic in many areas of Europe, we have reduced the emission of NO2, and this is visible on the concentration that is observed by satellite, because NO2 is a gas that is quite reactive. It is converted in other species in a couple of days. So once you reduce the amount of emissions, the concentration observed by satellite, it can be observed by satellite, responds quite fast. We switch now on China. We are still with the Sentinel-FIP measurements, and this is a way to show that with the satellite data we can also monitor what happens in function of time. And this is the evolution of the nitrogen dioxide concentration in China in the year 2020 is the top row, and in the year 2019, that is the second row, from January to April. And we do observe that in year 2020, after the reduction that correspond to the Chinese New Year vacations that has happened from the 24th of January this year and happened on the 4th of February last year, we have observed that in year 2020 there is still a phase of low NO2 concentration that are really likely due to the shutdown measures that reduce the emission over all China. While in year 2019 the concentration of NO2 has increased after the period of the Chinese New Year. And what is interesting to see is that in the last two frames that correspond to early April, we do see that there is a limited difference between 2 years, indicating that it is likely that the concentration and then the emissive activities are back in 2020 to similar levels to 2019. We can observe the same type of behavior in the Po Valley. The map below is the change of nitrogen dioxide concentration, and the blue means a negative change, so a decrease, and the decrease is of the order of the 40% in the area of Milan, that is the bluest, during the most strict lockdown period in Italy. And you can also see the time series that is on the right side with the year 2019 that is in gray and the year 2020, and you see that is highlighted in yellow. In the phase of lockdown there is a clear difference between the two curves, and there is a likely reduction again in the Po Valley, in the Milan area, up to 40%. This difference between the two curves lasted until early April, where two phenomena happens. So the first one is natural, is a reduction of pollution that we do observe every year. And the second one is also a possibility that the emission have slowly come back to a higher values due to the end or to the transition from lockdown to first activities, changing the composition of the atmosphere. We can also look back in the past with the satellite data, and this is an example with the GOM2 instrument that is on board the METOP satellite. And here we go back to 2007. From 2007, we have observed in the Po Valley a variability of the concentration with higher values in January compared to April that are marked in red. In January, the concentration are higher due to more intense combustion activity that lead to more NO2 nitrogen dioxide production. And what we have observed is that for the whole Po Valley area, so is a wider area, we still see a signal of reduction of nitrogen dioxide from this satellite that has a coarser resolution with respect to Sentinel-FIP, so can see the Europe more as a whole rather than a single town or a single metropolitan agglomerate. We still see a reduction in the month of April that is significant, likely due to the lockdown. This is another way to see the same signal. So we see the average behavior of the nitrogen dioxide in Lombardy from the beginning of the year until spring for the 2007-2019 compared to 2020, and we do see that 2020 is clearly lower with respect to the past. Even considering the reduction due to the seasonal cycle we have mentioned before. These data are also courtesy of the DLR from Germany that contributed to the EUMETSAT AC-SAF initiative. We can also look at the different species. We can observe the data from carbon monoxide. Carbon monoxide is also produced by combustion, but is produced by less efficient combustion. So is also produced by agriculture vehicles, heavy vehicles, aircraft, and so on. But has, with respect to N2, a longer lifetime. So it lasts in the atmosphere for a period of time of the scale of a month. The satellite observation from IASI, and that is thanks to two different instruments that are on board on two different elements of a generation of the METOP satellite from EUMETSAT, indicates that there is a general decrease of CO overall Europe. And there is a decrease of CO in northern Italy, but not all Europe is affected or sees a decrease of CO. There are also regions where the satellite data indicates some increase, and this is of course object of further research. And the same effect has been observed in China, and you see the data again from Sentinel, provided by the Netherlands S1 Institute, again on behalf of Copernicus, and we do observe in China from January to March 2020 a decrease in CO concentration. As we say, the CO has a long lifetime, so we can infer the fact that the actual observed concentration observed in March are the effect of accumulated reduction of emissions. We conclude our view of what satellite can provide as information for the COVID crisis effect on ammonia. Ammonia is a very volatile molecule. It's composed of hydrogen and nitrogen, and is produced by fast degradation of biota, and is emitted mostly by agriculture process. By more than 90% of emission comes from agriculture, and within the agriculture, the soil, so effect of fertilization, of degradation of the vegetation is about 1/3, while 2/3 is the manure. So it comes from livestock in farming, and we do see that emissions of NH3 and concentration of NH3 of ammonia are intense in areas where the agricultural activity is more intense in Europe, and again we see a hotspot in the Po Valley and in Netherlands, in south of Germany. And conversely, to the other species, we see that from 2017, the years in 2017 and to 2020, there is an increase. So 2020 we had more ammonia in the Po Valley with respect to the previous years. Of course, because it is likely that the emission have not changed due to the lockdown, and also one of the first hypotheses that is provided by the team in charge of the IASI, that is at the University of Brussels, hypothesize that there are more favorable meteorological conditions for the ammonia production. I go to the conclusions, and I would like to leave you with just a few points. As you have seen, satellites are a very important component to monitor our Earth. They're a fundamental component and can provide a global and integrated view. We can also derive quantitative information that we must treat with care. Of course, we must be aware of what is representative in terms of application that we can make from satellite data. Another great advantage is the variety of sounders and species, but this is also a barrier that we must uptake. So we need to choose, and we need to identify what information can come from each type of sounder and each type of species that we want to analyze. There is also continuous evolution, and there are new missions, and this especially in in the Sentinel program and the European program. So I want to make a small advertisement. We are holding with the EUMETSAT and in collaboration with the ECMWF in the frame of Copernicus. We are starting a consultation of experts to best prepare the community of users for the upcoming Sentinel-4 and 5 satellites and for the upcoming EUMETSAT missions. So please go to the link and participate in the activity. We start on June 23-25 with an online workshop. And also I would mention where to find the data. All the data are in general free of charge, and all the Copernicus European data are open, so you can access to them from the Copernicus Hub that is dedicated to the Sentinel-1, 2, 3 and Sentinel-5P and is supported by European Space Agency. I have also listed the series of data sources from EUMETSAT, including the ECSAF, so you can download from there and find there the data that have been presented here. And also I want to mention DIAS, that is a program that is supported by the Commission, and the EUMETSAT contributes to one of these DIAS, that is the Wikio, and the objective is to have an open architecture where you can have both data access and the cloud computing capability. I wish to conclude mentioning also the activities of training and learning. I mean, learning is a fundamental. We need to manage at the best the data and to learn how to use them and how to access them. And we have a series of training activities, and they go from hands-on approach, so from practicals and working workshop to online courses to massive courses like the MOOC for a larger public, and to the production of podcasts. So visit these resources because they are constantly updated with the new feeds and new information. I wanted to close with the chapter of data handling. There is also continuous development both in the frame of Wikio of interactive tools. One of the examples are Jupyter Notebook, and there is just a new release from EUMETSAT that you can obtain from the GitLab here. And these notebook are guided resources with pieces of code where you can work as a learning tool, but also provide very useful hints and useful resources for handling the data, for plot. Of course, everything is open source and available to the users. I stop here. I thank you for your attention, and I am available for any question now in the question time, and anytime you wish through my address and my contacts. Thank you very much. Stay safe, and I am very happy to talk with you now or in the next times. Thank you.
Thank you, Federico, for this very fine presentation. Well, I'm very glad to learn that many participants use the text box to submit the questions. So in the coming 10 minutes, up to 12:40, so 20 to 1, we have the time to answer some questions. I would like to start with a question from Sam, which was submitted in the previous session. So I will read it again. What's the update frequency and the maximum resolution of satellite images that can be freely available with the Copernicus program? So Stijn gave an answer, Federico. May I invite you to answer this from your perspective?
Yeah, sure. I mean, very nice to see you live, Martin, and to all the participants. Yes, the example that we have just shown is a good example. So, for instance, for the pollution, we go from the new satellite on Sentinel-5P that go up to 3.5 kilometer resolution on the horizontal, and this means that is at the scale of let's say of a huge town. While the past satellites The past instruments, as we have also seen, they have a resolution that is coarser, of the order of 10 to 15 kilometers. So having a high resolution is one of the big endeavors of Copernicus. Of course, it is changing function of the different variables that we do observe, but one of the objectives of Copernicus is really to provide data with a resolution at the scale of the human agglomerates. And concerning the time resolution depends on the orbit. So the geostationary, they provide the data continuously, observing always the same position, while the polar ones, they provide a sort of daily coverage or a coverage every 2 or 3 days. And of course, this is more dense in the northern regions.
Okay, thank you very much for the answer. Then I would like to stick to a question of Sam, because it's an interesting one, and I will read out. For machine learning purposes, is there a set of labeled data set produced by the different satellites for specific common items or scenarios? So
the question goes much in advance, because machine learning is one of the huge perspectives that we are facing. To my knowledge, there is not a specific set that is provided as a purpose for machine learning, but within the frame of Copernicus and of the service, it's very clear that machine learning is one of the applications that users may want to do and plan to do. For instance, there is a workshop that started to be organized by ESA, is the FEE workshop, and also there is a workshop organized by ECMWF, again, and ESA that has yearly happening. So please check also on the website of the partners in Copernicus, and there is the place to get more informed and also to participate to what is needed in terms of the users. Of course, this is a clear user need that Copernicus has to take on.
Okay, so thank you for illustrating that it's a system of collaborating entities, and not everything is linked to one entrusted entity exclusively.
Mm-hmm.
So another interesting question is from Noureddin. Maybe just to emphasize again, Federico, what's the difference between Copernicus and Sentinel in terms of use?
Sentinel is part of Copernicus. So Sentinel is the ensemble of satellites that are part of the Copernicus program. There are, as we have seen, 6 types of satellite, and there are multiple generation of satellite for each type. So we are talking about a constellation that will go up to 20 to 30 single missions. The availability is granted to the users and is for free. I mean, following the Copernicus rules. Copernicus, as we have seen, is a larger umbrella, but everything is produced by Copernicus. All the information is produced by Copernicus, is open to any user and is free and is accessible. And we do our best, of course, to make the access as best as possible in terms of usability, of training, and also of gathering the user.
Okay. Thanks very much for this answer. I hope it clarifies a lot. So Copernicus is the umbrella and the Sentinels are the satellites. Then Maria has the following question for you. Could you explain, please, how Copernicus could observe the results of economic crisis besides less transport concentration and pollution?
That's a good question. I mean, the main way to observe that is on the anthropogenic activities. And the impact of anthropogenic activities on the environment. I mean, the first one and the more straightforward, as we have shown, is to use the NO2 that is a reacting species and is deposited in the atmosphere, and then reduction in a pollutant that is produced by human activities. When the human activities are reduced, is the first benchmark. Of course, there are other ways, but are less easy to observe, and the effect of the change of the human activities that is a result of the economical crisis takes longer. So, for instance, the land use, deforestation, and also what will happen for the CO2. There are now studies on what is going on for the carbon dioxide, but it's less straightforward than observing the pollution. So the answer is yes, of course. I mean, we can also think about the marine activity, for instance, the ship tracking and so on. But again, the pollution is an example that is, let's say, easier because it's quite visible on a shorter lifetime, and the signal can be identified. For the others, of course, one of the application, one of the most important application for Copernicus is to understand and to quantify the effect of humans' pressure and the humans' presence on the Earth environment, of course.
Okay. Well, you addressed also the geographical coverage of the sentinels. We got a question in from Dr. Vladimir Kalinsky. So I'm just reading out. What about live video satellite feeds? What are the propositions for them? So also, are the data available, or is Sentinel covering other areas than Europe? So for example, West Indian Ocean in particular.
Yeah, sure. The satellite have a global coverage. So once you go and access to the data through the links that we have provided and we have discussed, you have global access. We have provided a vision on Europe because we are having a European-based workshop, and then there is a lot of interest. But Copernicus is a global problem. The proposition, to use the data, also depends on the users. And for instance, if you go on the sites of the services that have been mentioned by Stijn Vermoote, so the CMEMS, the CAMS, the C3S, you have many types of applications based also on satellite and assimilated data that, of course, goes beyond the European boundaries and can be applicable worldwide.
Okay, well, and I think then this also answers the question of Marika Tashvili,
yes.
Who is asking about does the coverage of Sentinel is available for the Black Sea region? So yes. The answer is yes, right?
Yes, so absolutely yes. It's a question of selecting the data there, and also do not hesitate to ask for support also through the help desk and the help links on the websites where you download and you have access to the data, of course.
So and then asking for help, Federico. This can be done by anyone directly to EUMETSAT, or do we have to go to a Copernicus central-based help office?
There are several channels for access to the Copernicus data, and it depends on the Copernicus mission. For instance, the Sea Hub Copernicus gives access to the Sentinel 1, 2, 3, and 5P. And here there is an help desk. This is managed by Copernicus and ESA. EUMETSAT has the CODA service, the EUMETView, and also the distribution of the new Sentinel 3 and Sentinel 5P. And of course, there is EUMETSAT help desk. And any registered user, but registration is free of charge and available to everybody, can of course put questions in the help desk, and in general, the help desk try to answer in a couple of working days for any type of questions.
Okay, and then also regarding, because I noticed from the questions, and I will combine a few questions so I don't read the names, is about how to interact with the entrusted entities and with Copernicus. Also, do you have internships or projects or any forms of collaboration which people can apply to?
Yes, sure. We have internship. For the moment, they are suspended for the COVID crisis, because we have in EUMETSAT we have internship that allow to travel to come to us, but also to travel in other institutions Europe-wide. Europe-wide because this is under the Copernicus hat. And there is a continuous rolling application, and you just go on the training pages of EUMETSAT and you find all the information. For the moment, we are reinforcing a lot the online training. With events like this one, providing specific support. And again, go on the training pages of EUMETSAT, and then you can find also the webinars of the past events and the announcement of the upcoming events. So please do so. Everything is free. Everything is open to any user, and all the material will be stored and recorded, made available for anyone. So absolutely, yes, we do our best to keep accessibility as maximum.
Okay, so there are lots of opportunities to collaborate.
Sure.
I think we have to come to an end, but there's an interesting question coming in from Sam. He's saying, can Copernicus data provide images showing light pollution in cities during the night? So, and is there a standard resolution of night images?
Yeah, of course. There are, in fact, there are images in general on the visible during night. And this is not my field of research, but I know that satellite data and also the Copernicus missions, here we are talking about the instruments working in the visible, so Sentinel-3, Sentinel-2 as well. So, I mean, watching as our eyes, and they are already used to detect the changes in land use, and of course also the consumption and the switch, for instance, to a different type of illumination. This goes back to the question of Maria. This is another way, for instance, to detect the effect of economic crisis and also the change, for instance, in the illumination type in the town. But sure, absolutely, there are data. The data are there, and to my knowledge, they are already used by the groups working on that.
Yeah, okay, and may I add to that, in tomorrow's session, we have 2 sessions dedicated to other systems which might help you to address questions on setting up businesses and collaborating and working with the Copernicus data sets as such. So, which brings us now to an end to this Q&A session with Federico. So thank you, Federico, again for your participation and sharing your expertise on the Copernicus system and on the activities of EUMETSAT. People can reach out. Presentations are available on the web page of the event. So this was also a question, so feel free to watch it again. And of course, we hope you will join us for the next sessions throughout the day or maybe tomorrow. And the next session will start at 1:30. So we'll hope to see you there. Federico, thanks again.
Thank you very much.
See you around in the near future. Thank you.
Thank you very much. Bye.